George throws a ball at a target 15 times. Each time George throws the ball, the probability of the ball hitting the target is 0.48. The random variable x represents the number of times George hits the target in 15 throws. So I think we can write down here that the random variable x will be binomially distributed with 15 trials and a probability of success of 0.48. And note that we don't have tables for that, so we're going to be using our calculator. So in part A, 1, we want the probability of x being 3. So for that, you need to use the binomial PDF function on your calculator and just do it for x equals 3. And for 4 decimal places, I get 0.0197. For part 2, we want the probability that x is greater than or equal to 5. That means we want a binomial CDF function. Now, some calculators will do the probability of x being greater than or equal to 5 straight off. For other calculators, you might need to use the fact that that is 1 take away the probability of x being less than or equal to 4. If we do it that way, it's 1 take away 0.0799, which is 0.9201. If your calculator does handle the probability of x greater than or equal to 5, you'll get to there in one step. George now throws the ball at the target 250 times. We want to use a normal approximation to calculate the probability that he will hit the target more than 110 times. The true probability here, or the true distribution, will be a binomial 250, 0.48. But we want to use a normal approximation. So, the first parameter here is going to be the mean. The mean for a binomial is to multiply n and p. The second parameter is the variance. To get that, you do n times p times 1 minus p. So 1 take away 0.48. And that's going to give us 120 and 62.4. We want more than 110 times, so that's the probability of y being more than 110. That is the probability of y being greater than or equal to 111. But we have to use a continuity correction because we are using a continuous distribution to estimate a discrete distribution. So when we look at the number line, if we've got 110 here and 111, and we're looking to go from here upwards, then the continuity correction says that we go from 110.5. So perhaps I should have changed those to x. We want x is more than 110. And therefore, when we use y, that is greater than 110.5. To 4 decimal places, because we can get this straight from the calculator, that is 0.8854